Hello everyone, this is Revati M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Science. In this series, we are discussing about the introduction and programming to data science. Today we are going to learn about support vector machine. It's shortly called SVM. So it's a supervised learning algorithm. It is both for both classification and regression problem. Classification and regression problem. The main idea of SVM is to find the best boundary called the hyperplane. Optimal hyperplane, which separate the data points into different classes or predict values. So it separates the data points and different classes, it predicts the continuous values. So SVM focus only on important data points called support vector. So it making it memory efficient and powerful. So these are the support vector machines. Because of this, it is a memory efficient and very powerful. Next, we see the core concepts of SVM. Now, let's understand some important concepts in SVM. First is hyperplane. So, it is simply a boundary that separates data points. Next one is a margin. It's a distance between the hyperplane and the nearest data points. So, this is a distance between the hyperplane, nearest data points. Here we are using the margin. Next, then we have support vectors. These are the closest points to the hyperplane and they are very important. That one is a separating a hyperplane between the nearest support vector. Here one support vector, here one support vector. It's separate. It's known as the margin, and it's the next one is a separating hyperplane. So a large margin means better accuracy and better model performance. If the margin is long, we get the better accuracy and model performances. Next, we see the linear or non-linear data. Now, let us talk about types of data. So, data will be divided into linear data and non-linear data. Here, linear data means it can be separated using a straight line. Non-linear data, it cannot be separated with a straight line. In real world problem, most data is non-linear. So, in SVM can handle this type of data using something called kernel function. So, here we are using the kernel functions. Next, we see the kernel trick. This is very important concept in SVM. Kernel trick helps us convert non-linear data into higher dimension space where it becomes easy to separate. So the best part is we do this without actually calculating the new features. So it saves computation time and makes SVM very efficient. So it saves computation time and makes efficient. It's simple. In simple words, kernel tricks makes complex data easy to separate. So here the input space is the feature space. It's mainly used to separate separation possible without extra computations. Now let's see different types of kernels used in SVM. Linear kernel is used for simple linear data. Polynomial kernel is used for when data has polynomial relationship. Next one is a RBF or Gaussian kernel is used for the complex data pattern. Next one is a sigmoid kernel. It is similar to neural networks. Okay, these are the types of kernel functions. Next, we see the SVM in action in classification. Next, we see what are the action we take in regression. So, in classification, SVM is widely used for classification problem. It divides the data into categories by finding the best hyperplane. It works very well even when the data has many features. It is commonly used in binary classification like yes or no or spam or not. Next, we see the SVM in action regression, SVR. So it can also be used for regression, which is called SVR. It is used to predict continuous values like mark, price, etc. Here we introduce something called epsilon margin. So error within the margins are here we ignored. So the model tries to fit the best line without working about small errors. Next, we see the what are the applications of SVM is used in many real world applications. It is used for face recognition and image classifications. It is used in text classification and for spam email detection. So in healthcare, it is used for disease prediction and medical diagnosis. So in finance, it is used for fraud detection and risk analysis. So SVM is very useful in many fields. So we come to the end of this session. Let's quickly revise what we learned. SVM is a supervised learning algorithm used for classification and regression. It finds the best hyperplane with the maximum margin. In kernel, tricks helps its handling non-linear data. In SVR is used for predicting continuous value. These are the key points you should remember. I hope you enjoyed this session. Thank you.